Welcome, my dear learners, for this course on engineering graphics. In our module 3, we are discussing about orthographic projection of solids. In the previous lecture, I introduced you people to the concept of orthographic projection of cone. In today's class, let us discuss one more problem on cone. Our problem number 18 states that a cone of 50 mm base diameter and 60 mm axis length rests on HP on a point on the circumference of its base, such that its apex is at 50 mm above the horizontal plane and its top view of the axis is inclined at 60 degree to VP. Draw the top and front view of the solid. Also determine the inclination of the axis when the base is nearer to the observer. Now, he is stating that the cone is resting on one of the point on the circumference on horizontal plane. Since it is resting on horizontal plane, in the first position I should make this cone stand on horizontal plane without inclining to any of the planes. So if I do that, in the first position, in the front view, I will see the cone as a triangle. In the top view, I can see the base, which is nothing but a circle. In the second position, I should show the inclination with respect to HP itself, because in the first position it is standing on HP. In the third position, I should show the inclination with respect to remaining plane, that is with respect to vertical plane. So the solution for the problem is, in the first position cone stands on HP. In the second position, apex is at a distance of 50 mm above HP, and in the third position, axis appears to be inclined at 60 degree to B. I repeat, in the first position cone is standing on HP, in the second position apex is at a distance of 50 mm above HP and the cone is resting with one of its point on horizontal plane. In the third position, axis appears to be inclined at 60 degree to VP, because he is clearly stating in the top view the axis seems to be inclined at an angle of 60 degree to VP. Since he is clearly stating it is in the top view, it is nothing but an apparent inclination given to us. Now, as I said, in the first position, first you draw the top view, which is a circle whose diameter is given as 50 mm. So therefore, take 25 mm as radius and draw a circle. Now, in our second and third position, since we are inclining the axis, we might encounter to draw ellipse or curve for base of this cone. In order to avoid difficulty in drawing the freehand sketch, a smooth curve, divide this circle into 12 or 8 equal halves. For simplicity, I have divided this diameter into 8 equal halves. That is, I have measured from the vertical point G 45 degree, 90 degree, 135 degree and 180 degree clockwise. Again from the vertical, I have measured 45 degree, 90 degree, 135 degree and 180 degree counterclockwise, and joining the lines, I divided the circle into 8 parts, 8 sectors. Now mark the points on the circumference. You will get 8 points. As I said, in the front view, if you view the cone seems to be like a triangle whose height is nothing but the length of the axis. So first you mark the axis length, which is given to be 60 mm. Now take the projections vertically upwards and connect to the apex. These interior lines which we have drawn are only for our reference. So therefore, these must be very thin lines. Whereas these longer edges, we have two longer edges, that is A prime to O prime and E prime to O prime. They are the longest edges available in our front view. These edges are termed as slant generators. As in case of pyramids, we call them as slant edges, because when I specify it is a slant edge is truly existing. When I term it as a generator, it is an imaginary edge. A cone truly don't have any edges. This completes the front view and top view. In the front view, observer will be here. To the observer, the point A, B, C, D and E are visible, whereas the points H, G and F are invisible. And also at the center, I have the axis. O is the apex point of the axis, O1 is the bottom point of the axis. Also show the dimensions of the diameter and length of the axis. So this completes the first position. Moving on to the second position, the apex should be at a distance of 50 mm above the horizontal plane and the cone should rest with one of its points on horizontal plane. So therefore, first you mark a line of 50 mm above the horizontal plane. So if I do that, I'll get measure 50 mm above the horizontal plane, mark an reference. Once I fixed a locus at a height of 50 mm above the horizontal plane, now according to him, the apex of the axis, that is O prime, should lie on the line which is 50 mm above the horizontal plane and the cone should rest on HP with one of the points on the circumference. So I can use A prime, O prime and incline the cone in the counterclockwise direction, or I can use E prime, O prime and I can incline the cone in the clockwise directions. This is because of the reason E prime O prime is equal to the length of A prime O prime. Since he has not given us the angle of inclination, but he is asking us to determine what is the angle of inclination of the axis with respect to the horizontal plane. So therefore, what we'll do is that we'll measure the dimension of E prime O prime and using compass fixing E prime on the XY line, cut an arc and shift O prime to a length of 50 mm above the horizontal plane. Measure E prime O prime. Now fixing E prime, cut an arc. Thereby I have transferred the corners E prime and O prime according to the given condition. The apex of the axis is at a distance of 50 mm above the horizontal plane. Now join E prime O prime. To transfer this base, measure the angle of inclination of this base with respect to the slant generator. If I measure, I'll get an angle of around 66 degrees measured counterclockwise. So transfer that inclination on the slant generator E prime O prime. Once you transfer the measured angle measured counterclockwise, now measure this base length, which is nothing but the diameter of this circle, which is 50 millimeters. Transfer that line to the marked angle. If I transfer, I will get. So thereby I have transferred A prime. So join O prime to A prime. This completes the given condition in which the apex is at a distance of 50 mm above the horizontal plane and the cone is resting on one of the points on the circumference on horizontal plane. Now measure these points on the circumference and transfer it. Thereby I have transferred B prime, H prime. At the center we have C prime, axis O1 prime and G prime, and also here we have D prime and F prime. Now join a very thin line to the apex from these points. Also mark the axis. So this is the required front view in the second position. Now take the projection vertically downwards and also from horizontal and mark the respective points on the base and also the apex. If I do that, I will get this completes taking projection vertically downwards and also from horizontal. Now marking the points, I will get A, B, C, D, E, F, G, H. For the axis we have O1 and O. Now in the top view, observer will be here. Since the base of the cone is inward, the portion of the circumference which is obstructed by the upper surface will become invisible. Only the outer surface of this circumference will be visible to the observer. Whereas in case of the previous problem, the base is inclined outward, thereby it is completely visible to the observer. Whereas in this problem, the base is inclined inward to the cone, so thereby only half of the portion which is coming above this two slant generators is visible to the observer, whereas the portion coming inward is invisible. So therefore, first you mark the portion which is visible, that is coming outside. If I draw a freehand sketch, I will get GHA, whereas the portion coming inward is invisible. Mark it with a dotted line, but it must be a freehand curve. So this completes the actual top view of the base. Now join the slant generators and also mark the axis with dashed lines and dots in between. This completes the required top view in the second position. Don't mark any slant lines from the points which you have marked, because further extensions are not required for our third position. So this is the first position and second position which is required for this problem. Now moving on to our third position, is clearly stating that the axis appears to be inclined at an angle of 60 degree to BP. He is mentioning it appears to be inclined is the reason because the true length of the axis is 60 mm, whereas if you measure the axis length, it is less than 60 mm, which means we have apparent axis. Therefore, he has directly given the apparent inclination. No need to calculate the beta angle. Just incline this axis at an angle of 60 degree to the vertical plane. And also, he is clearly stating the base is nearer to the observer. So therefore, the base should be nearer to the observer. First, you mark a 60 degree line inclined to vertical plane using protractor. Initially, I am marking 60 degree. Draw a reference line on this 60 degree marking. Measure the apparent length of this axis and transfer it to an angle of 60 degree. Thereby, I have transferred O and O1. Now, to transfer this base, first you construct a rectangle around the base. So if we do that, I will get the dimension of the rectangle . So transfer it. Now measure this length . Now measure the vertical lines from A and E . Transfer those lines also. This completes the transferring of the rectangle constructed around the base. Now mark the points on this rectangle. I have transferred the base with the help of constructing a rectangle around the base. Now draw a free and smooth curve . This completes the required diagram in the top view of the third position. Now take the projection vertically upwards and also from horizontal. If I do that, I will get this completes taking projection vertically upwards and also from horizontal. Now mark all the points. I will get A prime, B prime, C prime, D prime, E prime, G prime, and finally I have H prime. And also marking the axis, we have O1 prime and O prime. First you mark the axis. Now in the front view, observer will be here. Since base is nearer to the observer, the base is completely visible. Coming for the slant generators, the name itself indicates they are the imaginary lines. There is no question of verifying whether they are visible or invisible. So since they are imaginary lines, don't worry about the visibility and invisibility of slant generators. So only you should think of whether the base is visible or invisible. Since base is nearer to the observer, the base is completely visible. Therefore, join all these points with free and smooth curve. Better to draw a curve for 3 points first. This completes the marking of base with a freehand sketch smooth curve. Now draw a tangent from O prime to the circumference. So drawing tangents, we will get the final view which is required. As per the given question, the cone is resting on one of the points on horizontal plane. Finally, he is asked us to find the inclination of the axis with respect to horizontal plane. So therefore, using protractor, measure the inclination of this axis with respect to horizontal plane. If I measure, the axis is inclined at an angle of 27 degrees with respect to horizontal plane, because this line and horizontal plane are parallel. So therefore the angle of inclination of the axis, what he has asked in the question, is 27 degrees. And also in the final view, the axis is inclined at an angle of 51 degrees to HP. This completes the given problem in which the cone is resting on HP with one of the point on the circumference. Here also we can see that. And also, as he asked, the axis is inclined at an angle of 27 degrees to HP. As usual, I use the same color for these two front views, which means that these two front views are of same dimensions. For these two top views, I use the same color, which means that these two top views are of same dimensions. That's all from this lecture. Thank you.